Okay, good. Hi, everybody. My name is Michael Clark. Nice to see everyone come out today. So today I'm going to be talking about Android security. Specifically, the talk is a primer for hardening your Android apps, and the subtitle is Android Security Tips Using OWASP as a Guide, and I'll explain what OWASP is and why we're going to use that as a guide. But first, a little about me. Who am I? My name is Michael Clark Jr. I'm an Android developer for 4 years, like we said. I'm also an adjunct lecturer at NKU in computer science. Been teaching for a year now and got another class coming up this fall. I have my master's in computer science. I did some certificate or graduate level work in secure software engineering. And I did some thesis research in mobile vulnerability modeling. And if anyone would like to talk about that, anytime, come see me. I'd love to talk about any of this. I think most of you know me. Anyone that's not seen me or met me before? Hi, nice to meet you all. What is this? Why are we here? I know security is not necessarily the most fun topic, but it's an important one. It's something that I'm personally passionate about. I've spent a lot of time looking at. I would not call myself an expert, so to speak, but I have spent a lot of time studying it, so maybe you wouldn't have to. And the whole point of this is a little bit of awareness, really. OWASP, there's the next guide just came out. So there's the 2014 guide and the 2016 guide. And the 2016 guide just got released, and so I updated this talk. How many of you were at my talk last year at this GDG about Android security? A few of you, so you've seen a little bit of this before. So last time I went through each OWASP item one by one. We dove into some stuff. It was very dry, it was very boring. This time I changed it up a little bit. Hopefully it's a little more interactive. I like to have more of a conversational flow to my presentations. So stop me, ask questions. Don't just give me the deadpan stare like most of you are doing right now. Just you know, come on. You can ask me questions. Be interactive. So we're going to examine some common Android security risks, see some exploits, and then learn how to mitigate. And it's mitigate, not fix. You can't really ever fix something from. In the security world, we use the term mitigate because that's really what you're doing. You're solving it up to a point. It's never 100% solved in most cases.
Is Android, I mean, because you are expert on this, is Android more, I mean, from a security point of view, compare iOS, is more vulnerable to
that's going to be a contended, highly contentious subject depending on who you ask. In general, I think Android is attacked more, just because the language of choice is Java, and iOS is probably not as easily accessible to those who are, learning about security. So a lot of newer people will go to Android first. I see some looks from some of the iOS folks that maybe that's not true, and maybe it's changed a little bit with Swift, but I know Java is, taught at the university level, so that's a hard question to answer. If you look at some of the reports that are out there, Android has had some security problems, but they've gotten a lot better. So I don't want to speak too much to iOS and get myself in trouble, especially given some of the audience members. Alex. Okay, so OWASP, Open Web Application Security Project. It was founded in 2001. It became a nonprofit since 2004. It's an international organization, and it's a completely open community. Their whole point is that they're dedicated to enabling applications that can be trusted. Now, it has web in it, but we're talking about mobile. Well, in 2001, when this started, there really wasn't much of a mobile presence. It was more about web. That has since grown, and now they actually differentiate between the web vulnerabilities and the mobile vulnerabilities. So what is the top 10 specifically? In this case, for mobile, it's the representation of the mobile threat landscape. It was updated for 2016, like I mentioned, and it's the top 10 most common risks. And how do they gather that data? They actually do a lot of surveys from some of the industry experts. They do a call for data from a lot of the larger companies and small companies around the world and compile a bunch of information together. And they have a committee come up with, validated by experts, some of the most common exploits. And they do these every couple of years as needed to stay on top of things. If you look at the list for 2014 versus 2016, the list actually got updated a little bit. That's one of the reasons I updated this presentation. I also wanted to kind of get a little more interactive with this presentation, so hopefully you'll get to see some fun stuff towards the end. And really, the point of OWASP is a starting point. It is more of an awareness campaign. To understand security, there's a lot of depth, a lot of technical knowledge, and it can be kind of scary for people who are just getting into it or who have not had that kind of background. So understanding from a starting point is a good first step, even for larger enterprises and organizations. So what is the top 10? I have them listed out here. We're going to go through them one by one quickly, just so everyone can kind of get an understanding of what they are. And then I'm going to go into 3 of them in depth instead of all 10 like I did last time. And so we'll get an opportunity to see some code, ask some questions, that sort of thing. So number 1 is improper platform usage. This is the misuse of of something that the platform, in this case Android, gives you. So Android has a lot of security features already built into it. This covers the developer not correctly utilizing those features or trying to actively go against those features. This is one of the topics that I'm actually going a little bit in depth on, so we'll skip it for now. M2, insecure data storage, and it also covers unintended data leakage. They pretty much speak for themselves as to what that is. There's some data that's not secured. It does not include cryptography. Cryptography is its own section. That would be M5, M being mobile in this case. And they also combined it in 2014. They had these 2 split out between insecure data storage and unintended data leakage. They're the same thing now. Insecure storage and data is now exposed. We're also going to go into M2 a little more in depth. The first one that we're not really going to go in depth on is M3, which is insecure communication. It's the subject for almost its own talk all on its own, how to do this properly, but it covers basically everything related to SSL/TLS. So secure sockets layer, transport layer security, basically encrypting traffic to and from your mobile app. Incorrect versions, weak negotiation, all of those types of things are covered under this. There will be a tie back into M3 a little bit later, but I'm not officially going into M3 in this presentation. Questions so far? Okay. I can have a tendency to go a little fast, especially when I'm nervous. Always pretty nervous talking in front of people, even though I'm doing it more and more lately. So if I need to slow down, just say, hey, slow down.
Is there a specific Wasp package that you're downloading?
So it's actually, they've got their own website, OWASP.org. I can send that out in the notes. Adam, at the end, there's a place to host all of the files, like the slides and links and things like that, right?
Yeah, we can put a comment for this.
Okay. I'll get all of those relevant links, including like my GitHub profile, things like that. I'll get that all sent out afterwards to Adam, and they'll make sure it gets put up, so we'll have this. But you can go to OWASP.org, and if you search specifically for Mobile Top 10 2016, You can see, I've been hacked. You can see specifically what the top 10 are, how the list got made, some of the data, some of the presentations that they've given. And you can actually do things like join OWASP, which I recently did. So I'm proud to say I'm now an OWASP member. You can actually get an OWASP email address, which is pretty cool. They won't give me one yet for some reason. So if you watch this, say, where's it at? So number 4, insecure authentication. Sorry about that. Lost my notes a little bit here. This is authenticating the end user, or it can also be bad session management in general. But this is like the identity of the user when that is required. It could be maintaining the user's identity when that's required, or it could just be a general weakness in session management. Again, that could probably be, any one of these could probably be their own talk, and how to prevent each one. Also, I know this is Android specific and Android relevant. Mobile obviously applies to any mobile code, so definitely iOS applies here as well. Windows Phone, if that's your thing. It sort of applies to some of the hybrid style apps out there as well, but they also have additional issues and concerns, and not just from a security perspective. M5 is insufficient cryptography. This is anything related to cryptography and trying to secure sensitive information on the app itself. This is not necessarily, this is anything outside of the encryption that happens in TLS or SSL. That's covered under M3, but if the app somehow fails to use cryptography correctly, that's when it should. That actually more likely belongs in M2, which we're going to kind of see a little bit of that. But this category is for issues where cryptography was attempted for some reason and wasn't done correctly. So maybe you didn't use the right algorithm, or improper key management, things like that. Questions on the first 5? I went through them kind of quickly. We're going to go more in depth into 1 and 2 from the first 5. Okay. Part 2, the next top 5. Insecure authorization. This is failures in authorization, meaning the decisions that are in the client side, like not authenticating users where it should, so like granting anonymous access to some resource. Things like user identification. It's distinct from things like authentication, which was M4. Things like device enrollment, user identification, things like that. M7, client code quality. This one's used to be the security decisions via untrusted inputs in the 2014. It's one of the lesser used categories. This is a catch-all now for a code level implementation that's in the mobile client. This is distinct from everything that's on the server. This would be your traditional things when you think of about security exploits, things like buffer overflows, format string vulnerabilities, various other code mistakes, anything that would cause you to rewrite some portion of your code because of some traditional vulnerability. M8 is code tampering. This is things like binary patching, local resource modification. In iOS, that's called, I think, method swizzling. any kind of dynamic memory modification, smashing the stack, things like that. This is once the application is somehow delivered to your mobile device, the code and data resources are now resident on that device. The attacker can either directly or indirectly change the contents of that binary and then modify it in some way, and then it could be some direct method of subverting the intended use, which is a little bit different than reverse engineering, which is M9. M9 is the third thing that we're going to go into, so we're actually going to reverse engineer some Android apps. So hopefully that's the highlight of the presentation. It includes anything that is inside of the final core binary to determine source code, library, algorithms, any other assets that are in the code, opening it up. There are a lot of tools that you can use. We're going to use Java decompiler and specifically dex2jar to turn the APK into a jar file and look at an app that, a sample app that I wrote called Hackme, spelled Acme with an H, kind of a sample app. The idea of reverse engineering is that you can get a lot of information from the application that can aid in other attacks, and we're specifically going to see what those could be. It could reveal information like what the backend servers are, any cryptographic constants, what cipher suite you're using, any other type of intellectual property. If you have some kind of patented algorithm in the client code, then it's subject to reverse engineering. And we're not going into M10. And before I get into M10, are there any questions? Good so far. I know I kind of went through this. They're kind of dry. They're kind of bland. I went a lot more in depth into these last time. It's not the most interactive or exciting to sit up here and listen to all of these things. Yeah.
What's the difference between code tampering and client code quality? Is code tampering more like the code you wrote is fine?
Exactly. Code tampering is someone, the attacker is changing code to make it work a certain way, maybe changing address pointers or something like that in memory. What's that? Yeah. Or something like that. Versus client code quality, which is you specifically wrote something that's insecure, like a SQL injection or something like that. Yeah.
I think probably also falling under client code quality would be the ability to clearly understand what's going on, especially when you have, like, if you're handling data, which is especially sensitive, you want to keep things simple so that you know where it's going.
That certainly could be considered a security issue. So if you have a really complex app and you have developers who don't really understand what that app is doing, from a security perspective, that's a risk. That's absolutely a risk, and you can lump that in with client code quality in that case. So if you don't have a streamlined app or code base, that absolutely would be something that would be a concern for a security researcher or for your organization. So let's talk about M10, extraneous functionality. So I'll open it up. I'll make this more like a class at this point. What do you think is meant by extraneous functionality? And anybody who's went to the website can't answer. And if no one raises their hand, I'm going to start picking on my random friends. Alex.
Is it like when you've got some stuff in there that's either was it for testing or was there for development, and there's some way that can be exposed and can give you some other type of vulnerability, but you're shipping it in your production app?
Absolutely, that's exactly what it is. Developers included something in the app in production that wasn't supposed to be there, and maybe it's turned off behind some toggle or something like that. Yeah. Maybe it's turned off behind some toggle or some, dark launch type of thing, but some kind of system or code got released that wasn't really intended to. A good example, a developer may have accidentally included a password in a comment That's a simple example of it. Another example could be maybe you disabled two-factor authentication for testing, and you didn't take that back out, or you don't have it separated out the proper way, and so now when you ship that to production, your two-factor authentication is commented out. So extraneous functionality. That's one that has gotten so prevalent, especially in the mobile world, that it made the top 10. So it's a very easy one for us to mitigate. So I didn't really go into that. Yeah.
So, I mean, these are the top 10 based on frequency of occurrence, or is it like badness of it?
A little of both. It's mostly based on frequency of occurrence. OWASP does a good job on their website of it, kind of explaining their entire methodology. But really, it's a panel of the OWASP experts and committee members looking over the data that they got and finding what the most common things were. So the idea behind OWASP is if you could mitigate all of these top 10 risks in your app or in your organization for web or mobile, then you would be more secure than most of the other organizations or apps out there, even though it's only 10 things and there's many, many other types of attacks. In other words, this is the top 10 low-hanging fruit, so to speak. And that's why I think it's so notable that extraneous functionality actually made the list, that's happening so often. Maybe it was something that was committed into open source, GitHub or something like that, some passwords or other information that way. Wasn't necessarily in the app, but things like that. Yeah.
I guess kind of, I mean, I guess it's kind of, I would say also the fact that if you add functionality, you gotta look everything over again when you add new functionality.
Like regression testing?
Yeah, well, okay, so let's say you're looking at the perspective of, okay, where is my data going? Is it going where it should be going? If you add some kind of functionality, especially something that gathers data like monitoring functionality or something like that, you want to make sure that you got to go again to make sure that it's going where you think it's going.
Yeah.
That sort of functionality can be used by someone to extract data from the system.
Right, and we're actually going to see that that also kind of falls under the unintended data leakage, and we're going to see some examples of that. Any other questions? This is the top 10 proper. We're going to dive in just a little bit. No? Okay, cool. Improper platform usage. This is kind of generic. This is where most of you should start. It's M1. If you don't know anything about security, especially for Android, and you want to start, this is where you start. Know what Android gives you in terms of security. So it's basically Android Security Best Practices 101. This is first and foremost understanding Android's security model. That's things like the Android Application Sandbox. That can isolate your app and data and the execution thereof from other apps. That is, they also have robust implementations of common cryptographic functionality. They have permissions built in. They have secure inter-process communications. They have things like address space layout randomization or ASLR to prevent some of that code tampering and dynamic memory allocation stuff. You don't need to know exactly how all this works, but you just need to know that it's there and how you benefit from it. They also, yeah?
Why is the minimized number of permissions your app uses security?
So permissions are generally commutative in nature. So if something has access in your app to a certain set of things like contacts, then if you import, say, a library, like an advertising library that has some kind of bad code in it, now, since you trust it and you're saying, hey, all of my users that use this permission, I have access to contacts. Trust me, I just need access to contacts for this one little piece of functionality. But you're also serving up ads. And if you trust them and you shouldn't, now they can get access to the contacts as well. So you generally want to minimize the amount of permissions for that reason. Because trust is a chain, and the weakest link in that chain.
I wanted to add to,
Sure.
to that right there.
Please.
As an Android developer, just be careful about the permissions of libraries that you're using that get merged into your manifest. A lot of times you think about the permissions you're asking users to accept in your own app, but all the libraries that get merged in may have their own permissions, and those may fly under the cover. I know we've been burned by that a couple of times.
Also, it's like you don't want to be, and I guess this happens a bit too often, where it's like, where someone is going to ask, why does this app need this permission? And it's something that you got to explain, like, it doesn't actually need that permission. It's like, well, it says so.
Yeah. So that it's also not even from a security perspective, but there's a concept called psychological acceptability. So if your app can be the most secure thing in the world, but if a user doesn't want to accept it, then what's the point? So you have to balance your security with what your users will actually use and trust. So basically understanding Android security model. Make sure you understand how to do proper data storage. That's covered in M2. Always use the latest possible version of SSL TLS. That's M3. Another one of the tips is the permissions that we talked about. Really, there is a great training article on developer.android.com called Security Tips. It's a great place to get started. It covers basically most of the things that you would want to know about proper Android platform usage. So there's a lot more that we could cover here, but really just go out and kind of explore it yourself and see what's relevant to you. So I'll give you an example of something that is given to us by the platform. Our lovely example is WebView. So the code to the right is setting up a simple WebView. The sole purpose of this WebView is just to show static HTML content. So we see XML version, WebView, give it an ID, give it a width, give it a height. And then later on in code, we're inflating all that good stuff. And we load a URL, example.com. Problem is this code is doing something it shouldn't and exposing more risk than it needs to. Do you see what it is? Get the WebView web settings, my WebView, get settings, set JavaScript enabled, add JavaScript interface, and we're good. That's a lot of common code around using and implementing WebViews. What is it doing? And it's pretty obvious, I would think. What is it doing that it shouldn't? What's the additional risk that is turned off by default with WebViews? Anybody?
JavaScript.
Yeah, so that's one. Set JavaScript. Well, which one? Interface or enabled?
One current JavaScript, one current.
Both. Yes. Actually, it is both. Great. Someone got it. Add JavaScript interfaces you need to be particularly careful with. That's the more dangerous one here. That's saying that JavaScript could call methods inside of your code and do things that maybe you didn't intend that JavaScript to do. So that is definitely something that you have to watch out for. And if you're not prepared for that because you're just showing static content, that you're opening yourself up to risk. It's something that goes directly against the platform. It's an M1 violation. But just setting JavaScript enabled, if you're not running JavaScript, if you're just making static content show up, why would you even turn this on? So just leave it turned off, which it is by default, and just use what the platform gives you. It's a pretty simple example. It's something that a lot of people use WebViews for static content. So any questions about it? Pretty straightforward.
Oh, you're not going to HTTPS.
Oh, sure. Yeah, I mean, use SSL TLS, so an M3 violation, great, you know.
I guess I would add to that.
Sure.
I guess this is sort of specific to web stuff on
Uh-huh.
mobile. That you keep in mind that on a mobile device, you may be moving between Wi-Fi hotspots, and so it's generally just, you probably shouldn't trust HTTP without there's no telling what the router's doing.
Sure.
Essentially.
So my trivial example obviously has an additional vulnerability in it that I didn't intend, and that's exactly the problem is I didn't even intend for that. So it's a great example of a violation of M3 in this case. So M2, insecure data storage. Hopefully we start getting a little more interactive here. Basically the concept here is know what you're putting in storage. Internal storage is sandboxed, and if you look at Android's website, it'll actually say this is good enough for most usages. But no, I would actually say don't rely on that. Things like rooted devices or other apps that can break out of sandbox and get into your data can absolutely figure out a way to find any of the data in the insecure storage section. So just because it is, quote, sandboxed by Android, that is a good protection, but it's not 100% protected. So don't just rely on the fact that, oh, I have something saved in internal storage, it can never be read, no one's ever going to see it. That doesn't need to. That's not true. If you're doing inter-process communication, there's two flags that a lot of in the early days, it was called mode world writable and mode world readable. That's generally not something that is advised anymore on Android. Really, you should be using content providers for inter-process data sharing. That's just a best practice. The reason is you don't have any control of your data format or the applications that are requesting data to your app.
So does that mean that you could have two apps that theoretically are looking for the same namespace and accessing each other's data?
Yes, without going through any more security than that. If you really need to expose, even between the same namespace, use content providers. And external storage is public. So yeah, everyone can read it. So if you put something in external storage, by default, it's going to be seen. But that's really not the problem. The problem is if you are expecting certain data to be there, and since it is public, another app could come in and tamper with that. And they could set it to something that you don't intend. And if you don't intend for that data to be read in and you don't perform input validation on that, you could have buffer overflow, SQL injection, file injection, lots of other problems. So you're reading in some kind of data that was crafted maliciously by the attacker in this case. I'll give an example here of unintended data leakage. I know that was mostly around insecure storage, but unintended data leakage is definitely a problem with this. So the problem is, say you have sensitive information as output from your app, you didn't want it to be. A perfect example of this is logging. So you overlog sensitive information that may have only been for debug purposes. So you never want to log out things like credit card info, passwords, etc. We'll try to do a live demo of this in the app that I have, but I got a screenshot of it there. If you can see right in the center, the Hackney app, outputting to logcat, email at user.com, password, secure password. I'm logging that out in plain text. Now, I did it with a debug statement. So another interactive portion. When using Android logging, the different log levels, do you know which ones actually get output and during debug time versus just normal runtime? Does everyone know the 5 log levels? So let's start there. The 5 log levels are verbose, so that's the most verbose, the most logging that happens. And then D is reserved for debug. That's for debug-related information. And then there's informational, error, and warn. I think there's also a WTF as well. So, actually, info, error, warn, and I believe even WTF all will get output at runtime. Debug and verbose get suppressed.
What does WTF stand for?
Did you ask during
Well, that's funny.
Politically correct.
I'll just say in the docs it says worse than failure.
Worse than failure. Oh. We'll go with that. Worse than failure. I like that. So it's a pretty trivial example. Let's see if I pull it up over here. Whoops. Let me close some files real quick, and I don't want to give away the end. Question? Okay.
So if you do a release build, the platform does not output debug to logcat?
Yeah, I believe that's true. Which also explains why you and I were having issues with that the other day. Of logging something out as a .v that we wanted to see in a signed build.
So in this
Yep.
case, it was logged higher than verbose or debug, right?
Actually, in this case, you can see, you see informational warning, warning, warning. I actually logged it out correctly as debug here. I probably, for demonstration purposes, should have done it as an I, just so it would have been a higher issue. But this also includes if you store the username and password in shared preferences, things like that. If you're storing it in plain text, that'd be another violation of insecure storage and unintended data leakage. So I'm trying my best to find, here it is. Okay. Exit out of it, is that my problem?
So then how should you store a username and password?
That's a good question. You really shouldn't, unless you absolutely have to. If you can think of a good reason to, it's probably because you're implementing basic auth. And if you're implementing basic auth, then there's not really a lot of help for you. Basic auth is a username and password provided solution. Unless you ask for the credentials on every call, you're going to have to store it for authenticated calls. So try to find a better authentication and authorization mechanism than basic auth. If you can't, you can fall back to encryption. And if you happen to get that right, then you have the problem of storing encryption keys. Where do you store that on the client? There is something, if you're on a certain API level, called a key store that you can utilize. If you're on a API level that doesn't support key store, which I think is below 18, then you won't have access to the key store, and I mean, at that point, you're kind of screwed. It's the best way to put it. There's not really a good way to do key management unless you hide it behind some other username or password.
Really, if you're talking about like an account on like a web service that your app talks to, then yeah, you probably shouldn't be storing it on the client at all.
Yep.
I mean, I guess basically you do the, is the right way to do it? Like you'd have them log in and then you send them back a token.
Right, and that gets into like OWASP and things like that. That's the right way to do it. So for some reason, here we go. That's what I'm missing.
I guess on the other hand, there are some special cases where the app itself needs to do its own auth.
So here is login activity. This is actually taken directly from, yep, sorry.
Get a little bigger text.
Yeah, does anyone know the command shortcut for that right off the bat?
View presentation. There's not one by default.
There's not one by default, great. All right, presentation mode's kind of,
Hey.
is that better?
But the keyboard shortcuts are good.
Yeah, just got to remember them, that's the problem. I have all this security knowledge and it pushed out all my keyboard shortcut knowledge. So store values at the time of the login attempt. Here's where it gets the email from the text. Here's where it gets password from the text view. And then you see log D, I'm logging out the email and the password. There's really not much more to it than that. I guess the fix would have been, if I had done this correctly, instead of having an I, it would be a D or a V. But really, don't do this at all. Either debug or there's some fancy things you can do with product flavors or build variants or things like that. But again, not recommended because you might be a problem. You might come into a problem with M10, which is extraneous functionality. If you don't manage that correctly, you might accidentally send logs out the door that you didn't mean to. So that would be a violation of both M2 and M10. So D or V in this case. But really just don't log out anything that's this sensitive. Passwords, credit card infos, things like that. Questions? Okay, let's get out of presentation mode. But that's not the one you're all here to see, right? This is the one you want to see. Reverse engineering. I'm going to attempt to keep the screen on. Now let's talk a little bit more about it first. So first thing you need to know is your code isn't safe. What I mean by that is the code that you actually ship on as a binary to your users' devices is not safe. Anything that is in that, including resources, strings, XML files, all of that will be visible in some way, shape, or form to the users. And obfuscation is not security. Now I know you're thinking, well, ProGuard obfuscates, right? Obfuscation is not security. ProGuard is useful for shrinking and optimizations sometimes. DEX optimization is not as good as Java bytecode optimization, but it is not security. It is only annoyance to anyone who is truly trying to get into your app. It does help prevent only the lowest level of people looking at something. So if you're really lazy and you're not really committed, sure, it'll keep those people out. It's not going to do anything for the determined hacker. Specifically, we're going to look at a tool called dex2jar. It converts an APK to a jar file. And then there are many decompilers that are out there for jar files and Java class files. The one that I like that I've used is something called, I'm not sure the correct pronunciation is Perseon. There's also JD GUI and Fernflower, and there's an old one called JAD. So really, this is what we're doing. We're going to try this live demo. We'll see how it works. I'm going to try to attempt to use dex2jar and Perseon to decompile this Hackney app as soon as the screen comes back on. Give this in the review to Patrick, you know, Adam. If this works, we should see the code that gives us our API token. So here's our code. Token util, maybe we have some token for our API. We're going to call into some API that's protected by some token. You can't call it unless you know what the API is. A lot of APIs will use this. Where do you store that token? Oh, you're going to store it right there, this super secure token. And you're going to use the name getAPI token. But even if you obfuscate it or hide it, again, it can be repieced together, and we're going to see just that. So we'll see how this works. Attempts to do this live. And for this, I'm actually going to switch to mirrored mode because it'll be a lot easier for me to code at the same time. Okay. Let's Get Android Studio. I know how to get it out of presentation mode. There it is. I know it's hard to see. All right. Yeah. Don't really know how much you're going to be able to see my commands here, but I'm going to use the terminal that's built in to do most of this. And we'll see how it works. So I'm going to cd into my Hackney directory. And then I'm going to do Gradle wrapper, do a clean build. And then I want to assemble the APK. If that works. It's really fun doing this live. Also, Gradle takes forever, so if you need to get coffee or something like that, now's a good time for that. Wasn't being that quite literal, but sure. Gradle, 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 I made you out of code. Build successful, all right. The build can be faster, use Gradle daemon, yay. Get that warning all the time. Maybe I should look into what the Gradle daemon does for me. Okay. So now, I believe if I cd into my downloads, I believe I have a lovely, yeah, clear that. Every couple of minutes. So I have something called a decompiler. No. Separate it out for just a minute. Bear with me. Sorry, folks. I just did it actually like 2 hours before coming here, so. It's in the other terminal, not the not the code terminal. Yeah, that was my mistake. How I messed myself over. There we go. All right, here it is. Okay. Coming back over here, we're going to do sh dex to jar, not the zip. Law of demos. I knew doing this live was not a good idea, even though I just did it to prepare and all that fun stuff.
There's a shell script for it.
Yeah. It's one command, so. Yeah, I have it to the side. I'm just trying to find where my dex-to-jar is. Oh, I put it in documents, not downloads. That's a stupid mistake. Apologize. So, come on. Documents. So, sh dex-to-jar. Sorry, it's a directory. Apologize. sh dex to jar dash 2.0 dot sh, and then I give it the file that I'm looking for specifically. That is in source. Actually, I want to move it to my desktop to make it faster. So I'm using dex-to-jar. I've downloaded it from the internet. It is a script file, shell file. And I have the Hackney APK sitting there. I'm going to give it an out directory to put all this into, and I'm going to put it into desktop/Hackney. D2J. So the file in question, d2j-dex-to-jar.sh. That should do it. So you see it, arrow, hackme.apk is going to go into the desktop Hackney. So now, I'll come over here to desktop. Sorry. .jar. Specify. While that's going, I need to plug my laptop in. Something that my students always like to make fun of me for. They like to see how far I let it get before I remember to plug it in. And this time it got all the way to low battery. So don't tell them if any of you know them. Okay. So now we have the jar, hackme.jar on desktop. And now we want to use the Persione tool to decompile that. So that command I got saved right here. It's called decompiler. And that is in downloads, which is the problem that I was having. I got the command basically ready to go. Of course, I was doing it with something called test, but it's not going to be test. In this case, it's going to be hackme.jar, and I'm going to put it in a directory called hackme. So the first step takes the APK and turns it into a jar file. The second step decompiles those jar files, that jar into readable Java files. So desktop unable to access jar file, decompile it because I need to go to downloads, do that again. It's not called desktop, it's called desktop. Thank you. Man, law of demos, I love this. And it's not called Hack Me with a K. There's no K in it. Gosh. Hey, there it goes. Legal state exception. Not sure why I'm getting a legal state all of a sudden, so. Come on.
Yep,
Sued. Come on. Sorry, mistyping. Sude, Sudan, sudo. Still legal state exception. 1 second.
Has the directory already been created?
Possibly, yes. I think from that last mix-up. Thank you, Eric. Sudo Java jar desktop. Hack me and hack me. This is real world hacking, by the way. It's a lot of trial and error and waiting and frustration, and if I wasn't on camera cursing. Hey, there it goes, decompiling all this stuff. Yeah, it's not like watching Mr. Robot, even though that is pretty accurate compared to, he's just much better than I am, obviously. So now it's decompiling all the stuff, including all of the Android support libraries and all the other dependencies. So it'll decompile everything for you. There, done. All right. Here is the file that, or the directory rather, that it created, and you see Android. No, we want com, hack me package. There are my classes. Note that I didn't have ProGuard on, so if you look at my classes in my project, login activity, SSL socket factory, we didn't really talk about that, right? And that token util, that's what I'm looking for. Login activity we looked at earlier. We didn't talk about this socket factory thing. There's a reason for that. So I want to look at, hey, token util. I want to get at their API token. What is it? So if I open this Java file, it's going to open an Xcode and piss me off. There it is, super secure token. And I did it in Xcode, at least that way you can see that it was decompiled by Procyon. You see that it actually went through the whole process. And everything about the app is there in plain text. So it's that simple. Even if you know what you're doing, it would have been a lot faster. I obviously didn't know what I was doing fumbling around up here. So, but now something intrigued me. There's this SSL socket factory class. We didn't talk about that. I wonder what that is. So let's open that up. And it's over here. Decompiled by Procyon. SSL socket factory class. So they're extending SSL socket factory. So they must be doing some kind of TLS code here. And you see that in doing so, one of the things that they're doing is implementing a new trust manager. Okay, well, you know, if you don't know what that is, yes.
I was gonna say go to
Yeah?
Under text, or fonts and colors, sorry.
Yeah?
Presentation.
There we go. Hey, is that better? So I noticed that this code is also doing something with this SSL socket factory. So they're probably trying to establish a secure connection to some server out there. I have their API token, but maybe I don't need the API token. I noticed they're doing a trust manager. So if I know what this trust manager is doing, then I may be able to see how they're validating SSL certificates. Note that in check client trusted and check server trusted, they're given this X509 certificate array. And with that, you can do lots of things. In this case, they chose to do nothing. If you ever do this, Google will actually flag your app for Android M and above, Marshmallow and above, saying you cannot submit apps to the App Store with this code because you're not validating your certificates, at least from the server. And if you know that, huh?
Can I mention something about this?
Please.
So the whole idea of making your own SSL socket factories to get around self-signed certs not being approved for use on Android, it won't verify the trust chain for your certificate to do SSL. Well, there is a use for making your own factory. If you have a trusted CA, you can take its private key and put it into this trust and be able to go in and verify the SSL certificate you receive and trust that you have in your app.
You pass that in, you add it to this key store, and you pass in that key store to the class here in the constructor. And then that key store gets propagated through. But knowing that they're doing this, that lets me know that I can do a man-in-the-middle attack against them and impersonate the server, because they're not validating the server that they're talking to. So if they connect to, say, my Wi-Fi, and I have a URL that I can control that's pointed to me, instead of going to their API and using their token and all that stuff, now I can talk to them directly and gather a lot more information. So by using M9 in this case, reverse engineering, I've also exposed another vulnerability, in this case with the M3, the improper SSL TLS handshaking. So this is an example of how some of these actually play off of each other and cascade. So sorry for the pain of getting here, but an example of why some of these are important. And I think I'm running out of time, so I'll wrap up quickly. We don't have much left.
So what is the way we have to store the keys if you have to store when you write you are supposed to?
Well, that's a good question. So you're basically asking, what do I do, right? So I'll answer specifically how you store keys. Little or no security critical information on the device itself. That is key number one, not an encryption key. Use key store if you need to store an encryption key. If you have to store sensitive data locally, this may not be ideal depending on your use case. For example, if you're supporting API level below 18, you won't have access to use the key store. There are NDK solutions. They'll say, hey, put it in C++ code or C code, and that'll be more secure. Now they have to decompile C code. Well, there's another C code decompiler out there that works just as fast as these do, and you can get the information just as quickly. Obfuscating is just another level of indirection. So the point is, follow best practices and stay up to date. So if you need to store keys or some kind of sensitive information on the device, try to use the built-in key store, or in the case of credentials, I believe there's a credentials manager in some API levels. If you're on older API levels that don't have that support, try to upgrade quickly or try to minimize what's being stored on the device. Questions on that? The key point is start thinking about security. Hopefully after this you have some idea of how to get started hardening your apps. This is just the first step in a long journey. security is a process, not a product. Bruce Schneier says that. So, yeah.
I guess to add to like the question of like I need to store a key or something else secure. What do I do about that? Like a lot of that, because a lot of that does come down to like threat modeling and such. It's like, okay, what do I need to protect this thing from in the first place? Because it varies a lot from application to application. Like if you have a web service that's doing your authentication, then you're going to authenticate to the web service. It's going to worry about like key stores and things like that. And maybe you'll generate a temporary key that comes back or something. It's just going to be temporary. It's not going to ship with your code.
Sure.
Or maybe you have something where you could generate maybe in some case you can generate a key randomly on a user per user basis. So like again, it's not shipping with your code. Or maybe like maybe your app is you're actually making some sort of encryption or security app of some kind that where the purpose of the app is to create an encrypted store, in which case then you've got to worry about key derivation and things like that.
Yep. Yeah.
I mean, it really depends on, okay, what is this thing? What do I need to protect it against?
You're absolutely right, and you know, that actually brings me to kind of another point, not really related to encryption, but the mobile top 10 is for mobile devices, mobile apps. There is a web top 10 as well that go into things like cross-site scripting and all of that. But the problem with mobile that we all have is, and it's well beyond the scope of this talk, any non-trivial mobile app is going to have a web backend, some kind of API that it talks to. If you have that, then you have a whole other suite of problems. You're actually also susceptible to the web top 10. So don't stop here at mobile. Also learn about the web top 10. Again, that's a whole nother talk or multiple talks. But you have to harden your systems that you control first before any of this really matters much. So I guess the last thing, I have this YouTube link here. Could not figure out how to embed a video, but I really love the point of this video. So, and then have thanks, happy face. Back. Stop it.
Going to edit, maybe?
Yeah. That's what I need to do. Exit presentation mode. There we go. There we go. Love doing things live. So great. Simpsons. Mr. Burns is very secure. All these layers of security, defense in depth. All that work. Back door, screen door wide open. So that shows that very interesting point that just because you go through all this trouble, don't just have something that's as simple as a screen door falling off the hinges protecting your information just as much. So.
I don't remember the company or the situation, but there was a scenario where they were trying to get into a locked data center, authorized people where something happened and they weren't able to get in. So after spending a couple hours trying to get through the door, and figuring out the password and unscrewing the door, they finally figured out they could just cut a hole in the drywall and walk right
Yeah. And again, physical security falls into some of the same traps. But that's it. That's all I have. I ended with this little, thanks. My Twitter handle is Michael Clark Jr. Email michaelclarkjr@gmail.com. Should have put my GitHub up here. I'll get all of those links and the slides to Patrick and Greg and Adam, and make sure they get them posted up to the Meetup site so you can have all of this. The code is out there public on GitHub. I'm Michael Clark Jr. at GitHub as well, so you can pretty well guess. It should be easy to find me. If there's no more questions before we go, sure.
What's the best exploit you've ever heard of?
The best exploit I've ever heard of.
Bash, or Bash.
Huh?
Bash
shell shock.
In general, or just Android?
Specifically for Android.
There was one when I was in grad school that I was reading about. It wasn't specifically related to Android, but it was executable on Android. It was actually a research paper about a brand new type of attack that is specifically for mobile web browsers, and Android and iOS are both affected. I believe it was called view ballooning, so you can go look this up. But basically, because the browser windows, yeah, everyone's going to go look it up now, because browser windows are smaller, certain views actually extend beyond the viewable window. And there was a way, and I don't remember it now, it's been several years, but there was a way that they exploited that fact to get outside of the little, I guess, for lack of a better term, sandbox that they were in by ballooning this view, and they were able to access parts of the site that you wouldn't expect. And there was a whole research paper dedicated to the model and how they did that. So that was the one that really stuck out. And it's a whole genre of attacks that are specific only to mobile web browsers on small phones.
It's like the rendering engine or something?
Yeah, it has to do with the way the rendering engine renders it for, you know, basically the site wasn't prepared for such a small window. And you can somehow balloon a view outside of the bounds and exploit that in some way.
So what is like the biggest, maybe not attack vector, but like attack target on an Android device? I mean, obviously most of these are pointed at some kind of API that hopefully has its own security layer for sensitive things like credit card information.
So that's a good question, and that's really one of the reasons why I picked the 3 topics that I did to go into. Sure, SSL, TLS is important. Some of the other ones, authentication, authorization, are important, but a lot of apps have figured out a way to solve that problem by using things like Google's authentication or Twitter or Facebook or something like that. So really, the 3 takeaways from this is that the things that matter most is make sure you use the platform security standards. That's probably the #1 thing, not understanding what security features are there. So to answer your question, that would be #1. And then #2 and 3, very quickly behind that, would be know how your storage is set up and how to securely handle your data that you're in charge of, particularly if you handle passwords or things like that. Try not to store them and get into some of the mess. And then lastly, know that your app can be reverse engineered, so you can't really truly hide anything in your code or resource files or anything like that.
So it's more kind of about protecting you and your code base from your users as opposed to protecting your users from
Yes.
others.
Yes. And it falls into the same category as protecting a browser. And in a lot of cases, they say don't store things in a browser on the web. Do everything on the server because those are boxes you own. Your Android app is in the hands of all of your users. And so not all those users are going to be good users. Some of them are going to be malicious. And so you have to prepare for that. I mean, they really own that code at that point. Any other questions? Everyone ready to go drink?
Julie.
Yeah.
So is Asahi still the go-to product to handle security? Because I use Asahi for web. Is there a module I can use for like a plugin for Android as well?
What was the?
Asahi.
A-
I guess HDIV. You know the.
I don't think I'm not really familiar with that. And that kind of goes back to the quote that I had, which was security is not really a product, it's a process, it's kind of a way of thinking. So there are a lot of tools, products out there that you can use to help you be more secure, but again, it comes down to understanding what that tool provides you, why it helps you out. I mean, it's going to save you time, but yeah.
I guess sort of expanding on the point of like that. Okay, if the app is in the hands of your users, then your users can do whatever they want with it, pretty much, or just assume that that's the case.
Yes.
I mean, I guess by the same token, it sometimes helps to like think of what you got to deal with desktop apps.
Yeah, it's similar to like desktop
Yeah,
apps.
it's
Yes.
basically similar to desktop apps. You're going to have a lot of the same concerns.
I didn't draw a lot of those parallels because most people are web and mobile these days. You don't get a lot of desktop app security issues. You can also easier control desktop apps to a certain extent, depending on the type of desktop app that.
Not really.
We currently, I'm
Yeah.
.NET developer and stuff like that. Our main platform is all through RDP, and we just rolled out a standalone application that has to authenticate with the licensing server. And we were racking our brains trying to figure out how to basically make that secure, because once your code gets on their actual machine, it's pretty much impossible to really to store that stuff.
And it's the same problem that mobile faces.
Yeah, so it's the same thing. It's just a different.
Really, at some point, it's like, okay, we're just going to store what's relevant to this user. So if this user wants to mess up their own stuff, that's kind of. I mean, at that point, it's like, well.
I think one of the biggest lessons in all of this is if you write code for something in your mobile app, people have access to it. So don't write code that you don't want them to have access to.
Yeah, thank you.
It's,
Don't write code that you don't want them to have access to.
that you can walk around and get items and catch things, and you have a GPS provider in the app, and you have this nice little Bluetooth provider that has a nice interface. You can just go and swap something out on it. Things get a little interesting. So.
That does bring up an interesting point, because it's like, I guess that does go to like the code tampering thing. I guess, I forget what it was, like a bunch of people sideloaded Pokemon Go or something. But it's like, I guess this is sort of an Android thing where on Android, now thankfully most users aren't going to do this unless they know what they're doing, but you can install apps outside the App Store. And I mean, with that comes with, you got to do all the basic things about providing, random download on the internet. I mean, it's like your download links, you're going to want to have HTTPS, and if you're going to provide just the download link willy-nilly, I know not everyone's going to do this, but provide a signature for it. Does everyone know how to do that?
I think it's more worrisome because people that don't know what they're doing are still turning on that permission to allow sideloading things. You don't have to worry about people that know what they're doing. You have to worry about all the people that read the articles on Lifehacker that teaches you how to do it with no expertise.
A lot of the apps you're going to sideload are doing some shady stuff anyway, so you got to watch out for that.
Well, not necessarily. An example is the Sunshine app that just came out on Android. Yeah, it's only available in Canada. I wanted to try it out, so I couldn't go to the Play Store to get it, so I sideloaded it. But
that's not the majority of the
not at all. Not at all, but it's not always malicious users are up to something on that app. But
just remember, physical access is